Hi there, this is a video on section 13.2, which is about factoring trinomials, and this is going to be part 1. In part 1, we're going to be factoring trinomials of the form x squared plus bx plus c. So of the form x squared plus bx plus c. Okay, where b and c are going to be integers. So to factor trinomials of this form, we're going to use what's often called the x method. So the standard way of doing it is you make an x. Okay, so this is called the x method. You make an x, a large x like this, and then on the top you have c, and then on the bottom you have b, and then you have to come up with two numbers. So you come up with two numbers. So find two numbers that multiply to c but add to b. Okay? Find two numbers that multiply to c and add to b. Okay? And probably the easiest way to do it is by example. So let's see an example of this. But the idea is you want these numbers to multiply to the number on the top and then add to the number on the bottom. Okay, so let's do an example. Okay, example. Factor the trinomial completely. Factor the trinomial completely. By the way, trinomial means that it has three terms. So the word trinomial has the prefix tri built into it, and tri means three. Okay, so three terms. And we're going to do a bunch of examples, but we're going to start with a relatively easy problem and work our way into the harder ones. Okay, so problem number 1 is going to be x squared plus 7x plus 6. Okay, so like I said, you want to put the third number, which is c, on the top, and then the middle term's coefficient, which is b, on the bottom. And then you want to find two numbers that multiply to the top and add to the bottom. Okay, so in this case, our x squared plus bx plus c is going to have c is 6 and b is 7. Okay, so when we do the x method, we draw a large x, and on the top of the x we write c, so that's 6, and then on the bottom of the x we write b, which is 7. And then we want to find two numbers on the sides of the x's, on the sides of the x, that they need to add to 7 and they need to multiply to 6. They need to add to 7 and multiply to 6. Okay, so they multiply to the number on the top and they add to the number on the bottom. So if you think about it, the only options here are we could do, well, to multiply to 6, we can do 2 and 3. But 2 and 3 doesn't work because 2 plus 3 is 5. So the only other option is if they multiply to 6, then you could have 6 and 1. And 6 and 1 works because 6 times 1 is 6, but 6 plus 1 is 7. So that means we got it. Okay? And then these two numbers that we came up with, that's actually how this is going to factor. So now this whole thing is going to factor as x plus 6 times x plus 1. So the 6 and the 1 came from over here. So we're plugging in 6 and 1 for these two. So that's actually the whole problem. So that's not so bad. Okay, so this is our answer. The quantity x plus 6 times the quantity x plus 1. Alright. Now this one was pretty easy because everything was positive, so it was easy to think of the numbers that work. So let's see some ones that have negatives. Okay, so problem number 2 is x squared minus 15x plus 56. X squared minus 15x plus 56. So once again, we're going to use the x method here. And on the top of the x, we put 56. And then on the bottom of the x, we put the middle term, which is negative 15. And then these two numbers on the sides have to multiply to 56, multiply to 56, and they have to add to negative 15. So if you think about it, if they multiply and give you a positive number, but when you add them you get a negative number, that actually means they both have to be negative. Now why do they both have to be negative? Well, a negative times a negative gives you a positive, which is what we want, a positive 56. But a negative plus a negative gives you a negative, so that'll add to negative 15. Okay, and then we just need to try different numbers. And the standard way to do this is to try numbers that multiply to 56 until you find ones that add to negative 15. So for example, with 56, probably the numbers that you think of with your times tables is 8 times 7. So let's try negative 8 and negative 7. Well, we lucked out. This problem's pretty easy. So negative 8 plus negative 7 gives you negative 15. So these check out. Okay? But both of these numbers are negative. So that means the way this is going to factor is it's going to factor as x minus 8 times x minus 7. So it's always of the form x, and then you write the first number that you got, times x, and then you write the second number you got. But here both of them are negative, so we've got a negative 8 there and a negative 7 there. Okay? So the negatives make it a little bit trickier, but hopefully not too bad. Okay, so let's take a look at number 3. Okay, problem number 3 is x squared minus 5x minus 24. X squared minus 5x minus 24. So once again, we're going to use the x method. And the third term, negative 24, goes on the top. Actually, let me make my x a little bit bigger. So negative 24 goes on the top. And then the second term, negative 5, goes on the bottom. And we want two numbers that are going to multiply to negative 24, but add to negative 5. So if they multiply to negative 24, that means one of them has to be negative and the other one has to be positive. And the reason that is, well, if you think about it, a negative times a positive gives you a negative. But a negative times a negative gives you a positive. So one of them is going to have to be negative and the other one's going to have to be positive. Okay? So that's the only way we get negative 24. And then we think of numbers that multiply to 24. So for example, when I think of 24, the first two numbers I think of are 6 and 4. Well, if we do negative 6 and positive 4, negative 6 plus 4 is not negative 5, so that did not work. And also if we do -4 and +6, we get 6 minus 4 is 2, so that's also not -5. So what that means is 6 and 4 does not work. So we need to think of two other numbers that multiply to 24. So we tried 6 and 4. That did not work. So what are two other numbers that multiply to 24? Well, 8 times 3 is 24. So let's try 8 and 3. So if we try -3 and +8, we have -3 times 8 is -24, but -3 plus 8 is +5. But we actually want -5. So the order we want is actually -8 and +3. Okay, -8 and +3. Because -8 plus 3 gives you -5. So that works out. Okay, so that means this whole thing factors as x minus 8 times x plus 3. X minus 8 times x plus 3. And by the way, if you're doing your homework and you notice the order in which you get your answer is different from what they did, don't stress out. Because remember, when you're multiplying, the order doesn't matter. So you could have also gotten the reverse order. So you could have had x plus 3 times x minus 8. The order doesn't really matter. Okay? So this answer is just as correct as the first one. So switching around the order of the factors makes no difference. Okay. All right. So let's take a look at problem number 4. I want to do a ton of examples here. Make sure you see all the different cases. So problem number 4 is x squared plus 8x minus 9. X squared plus 8x minus 9. So using the x method, we're going to have -9 on the top and 8 on the bottom. So we want two numbers that multiply to -9, which means one of them has to be negative and the other one has to be positive. Okay? But if you think about the numbers that multiply to -9, you've got 3 and 3. But if you do -3 and +3, those add to 0. Those don't add to 8. So 3 and 3 is not going to work. So instead of 3 and 3, we can try 9 and 1. Because -9 times 1 is -9. But if we do -9 and +1, if you add those, you actually get -8. But we want +8. So we got to switch the order around. So we're actually going to be doing -1 and +9. Because -1 times 9 gives you -9, but -1 plus 9 gives you +8. Okay, so we factored it. So this whole thing factors as x minus 1 times x plus 9. Or the order can be switched around. You could have x plus 9 times x minus 1. That's equally correct. Okay, let's take a look at problem number 5. So problem number 5 is x squared plus 5x plus 3. X squared plus 5x plus 3. So using the x method here, we know that we're going to have a +3 on the top and a +5 on the bottom. Now we need to think of numbers that multiply to +3, but they need to add to +5. Well, if you think of numbers that multiply to 3, there's only one choice. There's only 3 and 1. Right? So it's either 3 and 1 or 1 and 3. And they both have to be positive because they multiply to a positive and they add to a positive. But if we try 3 and 1, +3 and +1, 3 times 1 is 3, but 3 plus 1 is 4, and we want 5. And you can switch the order, but it doesn't make any difference. So 1 and 3 is also going to add to 4. It's not going to add to 5. So 3 and 1 does not work, but that's the only possibility. That's what's called the only factor pair that multiplies to 3. And it doesn't add to 5. So what that means is this cannot be factored. Okay, so if you try all the factor pairs, you try all the possible things that multiply to the number on the top, and none of them work, that means it cannot be factored. Or some people like to say unfactorable. So what do we write as our answer if we can't factor? Well, we actually just write prime. So prime means you cannot factor it. So that's how we write our answer. Now prime just comes from the same idea as a prime number. So a prime number is a number that can't be factored. So a prime polynomial is a polynomial that can't be factored. So that should make sense. Okay? Alright, so let's see some more of these. So number 6. Problem number 6 is x squared plus 15xy plus 56y squared. X squared plus 15xy plus 56y squared. So now this one's a little bit different. We're still going to use the x method, but notice we have two variables. So for this to work out, since we have x and y, instead of writing our answer in the usual form where we have x plus the first thing times x plus the second thing, our answer is going to have to be in the form where we have a y. So it's going to need to be in the form of something times x plus something times y times something else times x plus something else times y. Okay? And to get x squared, all we need is x and x. So that's just going to be x and x. But here, we're going to need something in front of y for each of these. So these are the numbers we need to find, is what to put there. Okay? So we're still going to do the x method. But on the top of the x, we're going to have 56. And on the bottom, we have 15. It's just now we're going to have a y in front of each of the numbers that we get on our answer. Okay? So we want two numbers that multiply to 56, but add to 15. Well, this is pretty easy. 8 times 7 is 56, and 8 plus 7 is positive 15. So the numbers are going to be 8 and 7. But the tricky part is, how are we going to write our answer? It's actually going to be x plus 8y and x plus 7y. So in order to get the y squared at the end, that's why we had to have a y here and a y there. That way, if you multiply it out with FOIL, it actually multiplies out to this original polynomial. And you can actually check these with FOIL. You can check it with FOIL. You don't have to check it with FOIL. It's not required, but it's nice to know how to do it. So if you take this polynomial that we have here, where we have it factored, and you multiply it out with FOIL, you're going to get x times x, which is x squared. That's the first. The outer is going to be x times 7y, so that's going to be plus 7xy. The inner is going to be 8y times x, so that's plus 8xy. And then the last is going to be 8y times 7y. So that's going to give us 8 times 7 is 56, and then y times y is y squared. And then if you combine the two middle terms, you combine those, then you get x squared plus, well, 7 plus 8 is 15xy plus 56y squared. And that's actually the polynomial that we started with. We started with the same polynomial here. Okay, so because it's the same one we started with, that checks out. So that means we factored it right. And you can actually use this on any problem. Once you get to your answer, you can multiply it out with FOIL and see if you get the same as your original polynomial that you started with. Okay. All right, so that was number 6. Let's take a look at problem number 7. So problem number 7 is 21 plus 22m plus m squared. 21 plus 22m plus m squared. So the thing about this one is it's not written with the highest powers first. So before you factor, you have to write the highest powers first. Write the highest powers first. And there's a name for that. If you write a polynomial with the highest powers first, that means you're putting it in what's called descending order. Okay, and descending order, it's called descending order because you have the highest power first, and then the next highest power, and so forth. So it's descending in powers as you go from left to right. Okay, so here, the highest power is going to be m squared. So we need to write that first. And then the next highest power is going to be 22m. So we write that second. And then the last power is 21. Well, that isn't even a power, it's just a number. It's constant. So 21 goes last. Okay, but once you write the highest powers first, that's the only trick you have to do here. And then the rest of it's just like the other problems we were dealing with. So now with this, we can actually just use the x method. Okay, so on the top of the x, we have the third term, which is 21. And then on the bottom of the x, we have the second term, which is 22. And then we want two numbers that multiply to 21, but add to 22. So we can try, we know that 7 times 3 is 21, but 7 plus 3 is only 10. So 7 and 3 don't work. So think about other numbers that multiply to 21. Well, there aren't a whole lot of them. Actually, the only other option besides 3 and 7, which didn't work, would be 1 and 21. Okay? Because 1 times 21 is 21, but 1 plus 21 is actually 22. So we found the numbers. So that's good. Okay, so those check out. So that means we factor this as m squared, sorry, not m squared. We factor this as m plus 1 times m plus 21. Okay? Pretty cool, huh? All right. So we've seen those. I think you should be good for those types of problems. All right, so now we're going to see a couple more tricks before we end. Okay, so problem number 8. For problem number 8, we have 4x squared plus 36x plus 56. 4x squared plus 36x plus 56. So what we have to do here is, because the highest power isn't just an x squared, it actually has a number on it, what we're going to have to do is we're going to have to factor out the GCF first. Because I notice here 4 goes into 36 and 56, So I can actually factor out the GCF first. Okay, so factor out the GCF first. Okay, and that's why we had that other video on how to factor out the GCF. That's actually a helpful thing here. So looking at these numbers, the biggest number that goes into 4, 36, and 56 would have to be 4. Because 4 goes into 4, 4 goes into 36, 4 times 9 is 36, and 4 also goes into 56. If you're not sure about that, you can always use a calculator. Do 56 divided by 4. Okay? And I believe that's 14. I believe it's 14. Okay? So anyway, we can factor out a 4 because the GCF is 4 here. So if I factor out a 4, what am I left with? Well, I have x squared plus 4 times 9x is 36x. Plus, well, 4 times what is 56? Again, if you're not solid on that kind of stuff, you can always use your calculator. So if we do 56 divided by 4, that gives us 14. Okay, so that means we've got to have a 14 here. So we have 4 times x squared plus 9x plus 14. So since we factored out the GCF first, now what we can do is we can factor this polynomial on the inside, but we can leave the 4 out front. Okay, so now that we factored out the GCF, now we use the x method. So now we factor normally. Okay, so the 4 just stays out front, and then we're going to go ahead and use the x method. So, but we're using this polynomial inside of the parentheses. So we're going to have a 14 on the top and a 9 on the bottom, because that's our middle term here. And notice the 4 doesn't show up at all. So we want two numbers that multiply to 14 but add to 9. So with 14, right away, most people think of 2 and 7. And 2 times 7 is 14, but 2 plus 7 is 9. So that means these check out. Okay? So that means we still have a 4 out front, but it's going to be 4 times x plus 2 times x plus 7. Okay? So I actually brought the 4 out front, and you don't want to forget about it in your answer. But we factored this inner part the same way we usually would. It's just there's a 4 in front of all this in our answer. So our answer is 4 times x plus 2 times x plus 7. Okay? Alright. So that's most of the tricks that there are to learn here. Looking through your homework, I think you should be good for most of this. The only other one I wanted to do was just maybe one more of the hard problems. Okay, so this is this next one is similar to problem number 20 in your homework. Okay, so example number 9 is 6x cubed plus 42x squared plus 72x. 6x cubed plus 42x squared plus 72x. So just like with the last problem, this one would be very difficult to factor the way it is, which is why we need to factor out the GCF first. Okay? So what's the GCF going to be here? Well, looking at the numbers, we want a number that goes into 6, 42, and 72. Well, 6 goes into 6, 6 goes into 42, then 6 also goes into 72 because 6 times 12 is 72. So for our GCF, we're actually going to have a 6 for the number. And then remember for the variable, since all these terms have a variable, we go for the smallest power that's in common for all of these. So the smallest power in common is x to the first power, which is just this x right here. So our GCF is going to be 6x. Okay, so right off the bat we want to factor out a 6x, and then we have to figure out what's left. So if we factor out a 6x, we're left with a x squared for our first term, and then for our middle term, we know that 6 times 7 is 42. So for the middle term, we're going to have a plus 7x, because 6x times 7x is 42x squared. And then for our last term, we factored out the x, but 6 times 12 is 72. So we're going to have plus 12 for our last term. So we have 6x times a quantity x squared plus 7x plus 12. And you can always check these by multiplying each one. We know 6x times x squared is 6x cubed. 6x times 7x is 42x squared. And 6x times 12 is 72x. So we did it right. Okay, so there we factored out our GCF. And now we're going to go ahead and use the x method. And some people like to write the x directly below what they're factoring. That's a nice thing that some people like to do. So 12 is going to go on the top, and 7 is going to go on the bottom. So we want two numbers that multiply to 12, but add to 7. So when I think of numbers that multiply to 12, what I usually think of first is 6 and 2. So 6 times 2 is 12, but 6 plus 2 is 8. So that doesn't work. So what we're going to have to do is we're going to have to find another two numbers that multiply to 12. So instead of 6 and 2, let's try 3 and 4. Well, 3 times 4 is 12, so we're good there. And then 3 plus 4 is 7. So it actually checks out. Okay? So there are our two numbers. Okay, and don't forget we still have a 6x out front. So we're going to have 6x times a quantity x plus 3 times a quantity x plus 4. 6x times x plus 3 times x plus 4. And that's our final answer. Okay, so that is the end of this lecture.